Hi, my name is Kelly Aitken. I'm the Business Development Officer for the Digit Me Too project, which is a European Regional Development Funded project based at the University of Central Lancashire's Burnley campus. We provide up to 150 hours of fully funded support to help Lancashire-based manufacturing SMEs adopt Industry 4.0. Our team specialises in data visualisation, data analytics, IIoT, the Industrial Internet of Things, as well as robotics and automation. This video is part of a series of videos designed to give you a more detailed insight into each of these subjects. Please contact me using the details on the screen to discuss how Digit Me Too can help your company. Thank you for listening.
Hi there and welcome to the first of a two-part video on process mapping. My name is John Pinder and I work for UCLan as a digital manufacturing project engineer, where I mainly assist local manufacturing SMEs with the implementation and project management of Industry 4 projects. And these usually range from everything from advanced robotics and automation to data analytics using artificial intelligence. But before you can begin with any of these types of projects, you must first have at least a basic understanding of the process that you want to improve. So this video hopefully provides a basic overview of how to process map, how we can use 2D discrete event simulation to help us, and process improvement. Over the course of these two webinars, you'll learn how to identify key processes, understand how well-managed processes create value and generate customer satisfaction, discover the importance of process improvement, see how simulation can be used to reduce the risk of both capital investment and health and safety in light of the COVID-19 outbreak, learn how to use a process map to identify all of the key activities in a process, learn how to separate the non-value added activities from the value added activities, understand the importance of using the knowledge gained about the process to create the best possible process, and finally appreciate the implications of social distancing upon your process cycle efficiency value. So what do I mean by a process? Well, a process takes inputs and performs value-added activities on those inputs in order to create an output. So here we have inputs on the left. We perform value-added activities on those inputs, either by individuals, work groups, functions, machines, or even entire organisations, and we end up with an output, whether it's a product, a service, or maybe a result. If we look at a cinema example, and we say, well, if you want to go to the cinema, who's going? These could be the components. What's the show times and places? This could be the information, and the criteria is used for what sort of movie you want to watch. You then drive to the cinema, you buy a ticket and you watch the movie, which is the value added activities, and then the output is the entertainment value of the movie. And every business has key processes that it must perform well in order to attract and retain customers to whom they sell the products or services. So what actually is a process map? Well, some people refer to them as flowcharts, process flowcharts, or even process flow diagrams, but it's essentially a graphical representation of all the steps involved in an entire process or a particular segment of a process. It's used in the first stages of problem solving because it enables those studying the process to quickly understand what's involved in the process from start to finish. And problems or non-value added activities nested within a process are easily identified using a process activity map. And I'll provide a link at the end of this video so you can download a map yourself and have a go on using it in your own company. But when a value stream is mapped, the stream or the process is studied to determine what activities can be removed, combined or simplified. But the point is to eliminate the wasteful steps and activities in the process, in addition to identifying suitable data collection locations and information flows. So let's have a look at a few different process maps or process flowcharts. The one on the left is a testing process and primarily uses rectangles to represent operations and diamond shapes to represent decisions. Whereas the glove box assembly flowchart on the right mainly uses circles to represent operations and then uses upside down triangles to represent storage. So as you can see, there's different ways of representing these, but the important thing to remember is use whatever notation you like, but keep it consistent throughout your company. And here we have an example of process flowcharts being used as routing sheets, where they look very similar to the flowcharts we looked at before, but this time they have additional information on them. So we have process activities, which are, it goes from the routing sheet to labeling the unit, to inserting the pin, assembling the units, assembling the cover, and then finally test. But also we have additional operator self-inspection instructions, such as the orientation of the label adhesion. Is it flush with the surface? Is it greased? What's the position of the screw, for example? And then going one step further, we also have specifications which are indicated at the bottom left. So as you can see, we have the press force of the material, which is 12 pounds, and the amount of grease to be used, which is 2 cc's. And in line with Industry 4.0, we can also make this document digital by adding an NFC tag on the sheet, which can either read data or write data to be tracked in the process. So let's have a look at an example of how a made-up company, Company X, created their own process map. First, they defined the boundaries. The team examined the process from the customer's point of view, and they identified where the process begins and ends in the customer's experience. I'll explain a little bit more about what I mean by the customer experience in a few moments. Secondly, they defined the process steps. The team members brainstormed the steps in the assembly process, they double-checked the steps, and they observed the actual process, and they wrote each of these steps down on sticky notes. You then sort the steps into order of the occurrence in the process. So after they reconciled their observations with the brainstorming efforts, the team sorted the steps into the order of their occurrence. They then placed the steps in the appropriate flowchart symbols, and with these steps in the correct order, it was a very simple task to put them into the appropriate flowchart symbols and create their chart. Again, it doesn't matter what notation you use, but just try and keep consistent. Finally, they evaluated the steps for completeness, efficiency, and possible problems. The team reviewed the chart for completeness, and several team members were actually unaware of the complete process. So, because it creates a greater understanding of the process, this diagram with simulation will be helpful during the later problem-solving efforts. So with your process map now complete, it can then be useful to model this series of processes in simulation software so that you have a virtual reproduction of the current state of your manufacturing process that you can then experiment with. This particular type of simulation software is called discrete event simulation, and it's used to model the operations of a system as a discrete sequence of events in time. And every event occurs at a particular instant in time and usually marks a change of state in the system. There are many advantages to using simulation. One of them is being the flexibility to model various levels of detail and complexity. So whether you're modeling your entire factory or you're just modeling a specific process within that factory, it's up to you. It allows you to model the uncertainty of dynamic and time-changing systems. So every process doesn't always take the exact same amount of time to complete. Usually it does if it's a machine with a set cycle time, but you may also have manual processes which vary in time depending on which operator is completing the task. It also helps increase your understanding of the process. So just from a 2D simulation, you can gain a better understanding of things like throughput and machine utilization. With 3D simulation, you can see how different factory layouts and routing affects production. And it's now even possible to completely immerse yourself within a simulation using VR or virtual reality to experience what it's like to be there in your newly designed factory from a human-machine interaction perspective. Maybe you feel claustrophobic or can't see line of sight to important dashboards or machine warning lights, for example. And with respect to the current COVID-19 outbreak, a variety of newly imposed social distancing strategies can be tested virtually without potentially putting employees at risk from physical contact. Of course, there are some disadvantages to simulation, which are, like most numerical techniques, discrete event simulation provides only approximations or estimates of your model's outputs, but that's all that's possible for most complex systems anyway. And discrete event simulation is heavily reliant upon statistics, which most engineers are not actually that comfortable with. So here we can see a simple example of discrete event simulation in 2D. And in order to create this model, we first have to have done a process map to identify what the processes are, how long they take, And then we can put this information into the model, and then we can start to do clever things like speeding up the model and the simulation, maybe weeks, months, or even years into the future to see where bottlenecks may occur. This then gives us a good indication of where process improvements can happen. So when exactly would you use simulation? Well, when the system that you're studying has significant variability in the input variables, which will ultimately affect your results and the conclusions that you make about the effects of the changes on the output. When there's enough data available, or which can be collected to fully characterize the variability in the key input variables, hence the reason for creating a process map to collect all the data of times, processes, etc. And when the risk of making the wrong decision outweighs the cost of the simulation study. So obviously these simulation studies cost money to build and to model, but if you're going to put a new machine in that costs £100,000 and it's the wrong decision, then you've obviously made quite a big mistake. And it's not just the financial risks, but also the health and safety risks with respect to the social distancing procedures that we can monitor. So in the second part 2 video, we'll demonstrate 3D simulation in order to measure the effect of social distancing on various activities' performance and also observe the staff interactions without potentially subjecting them to physical contact with each other in their working environment. So I go through this effort of process mapping and then maybe simulating your process to identify problems. Well, the ultimate goal is to improve your process. And process improvement prevents defects and increases productivity by reducing process cycle times and eliminating waste. And it often occurs through value-added process mapping, which we'll talk about more in part 2, problem isolation, root cause analysis, and problem resolution. And the reason why you want to do process improvement is to generate value and customer satisfaction. And Henry Ford once said that time waste differs from material waste, and then there could be no salvage. So a wasteful factory consumes resources that may have otherwise been used to create valuable products or services, and these costs create nothing of value and are often hidden under the term overhead. Poor quality, long process lead times, and variability in products or services significantly affects the profitability of an organisation. Process management enables organisations to eliminate wasted time, effort, material, money, and human resources. And Lean Six Sigma organisations concentrate only on the value-driven improvements by recognising that processes should be measured and the results carefully analysed to identify opportunities for improvement. So as you can see from the flowchart on the right, there is a systematic way of carrying out this process improvement. The first being to determine the objective of the process as it relates to the customer, and then to determine the boundaries of the process as the customer sees them. What do I mean by this? Well, the process should be studied from the customer's point of view, as true process improvement always comes from knowledge of what adds value or meaning for a customer, and this is often referred to as the voice of the customer. And not looking at the process from the customer's point of view often leads to narrow definition of the process. And this narrow definition limits improvement efforts because it fails to study the customer's experience. A hotel manager, for example, may view the check-in process as being assigned a room and simply given the keys. Whereas a customer may take a broader view, seeing the check-in process to involve everything from the moment from when they arrive at the hotel door to when they are seated in their room with their shoes off. Improving simply the time it takes to receive the room key fails to take into account the customer's overall impression or experience, thus missing the opportunity to increase the customer's perceived value. The next step is to involve all the representatives from each of the major activities associated with the process in the improvement effort. Identify where conflicts exist between the boundaries of the process as they are related to existing functional departments. And crucially, identify who the owner of the process is. Identifying who is ultimately responsible for seeing that a process is completed in a manner that results in customer satisfaction. This is important because these individuals are in a position to make and have the necessary power to make changes to the process. And it's so important to involve the individuals from the key activities in the process in the improvement efforts themselves. The reason being that it creates buy-in, So if they're involved in deciding the changes, they will most likely keep to them. It breaks down barriers between existing departments, and it determines whether there are conflicts that exist between existing functional organisation structures and the newly emphasised process approach. By identifying these conflicts, leadership can take steps to minimise the difficulties associated with the transition. You can then begin to create your process map by identifying all the activities in the process. You then separate the non-value added activities out from the value added activities, which we'll look at very shortly in more detail, and then eliminate the non-value added activities. So every process always has value added activities within it and also non-value added activities within it. What we're trying to do is improve the flow of the value added activities, but before we do that, we focus on the non-value added activities. These consist of necessary non-value added activities, which we try to reduce, and the unnecessary non-value added activities we try and eliminate. You sometimes see these called necessary non-value added or business value added activities. Ultimately, processes evolve over time. A necessary activity in the past may no longer be needed because of changes in technology or changes in the desires of customers. We've always done it that way mentality without realising that they've always no longer needed to do it that way. Identifying these extra activities on a process map makes it easier to see that some of these activities may no longer be necessary and can be removed using tools such as the 7 waste, 5 Ws and 2 Hs, saving time, money and effort. So here you can see a much more detailed process activity map, which has the activities on the left, and then we state the flow in terms of whether it's operation, transport, delay, etc. We state the machine or the location where it happens, so goods in desk maybe, Henry's computer possibly, and we also indicate the distance in meters. We then also record the time in seconds of how long each activity takes and the amount of people that it takes. We then have the operations, which are the value added activities, and also the necessary value operations, which are value added in this particular case. And then all these, the rest of these are wastes or non-value added activities. So we've studied the identification of waste. We've then created this future process activity map highlighting this. We've considered whether the process can be arranged in a more efficient sequence. We've considered whether there's a better flow pattern, layout or routes, also including social distancing. So as you can see, we can observe where the people are walking and when they come into contact with each other. And also consideration of whether everything that is being done is absolutely necessary. So finally, you identify, analyse and eliminate any variations in the process, either using lean methodologies or some industry 4 technologies. You then determine whether the remaining value-added activities are truly the best practice. And again, we'll show you some tools and techniques in order to achieve this in the part 2 of this webinar series. And finally, you redesign the process using all the knowledge you gained from the first 9 steps to ultimately create a much more efficient process. So the process activity map that you saw on the previous slides was created in Excel, so it's quite easy to create some custom visualizations and analysis of this using pie charts, graphs or bar charts. And as you can see, it highlights the non-value added activities and the value added activities and the percentages of each and which areas they lie within. The analysis summary shows an elimination of 4 non-value added activities, and we actually added 1 value added activity in replacement of some of these in this particular case. So there's a total of 3 less activities, and the old process time took 2.62 hours. The new process time now takes 2.44 hours. So the process improvement reduction time equals 10.4 minutes, which you might think that's not a lot, but every day, 5 days a week or 7 days a week, this all adds up to quite a substantial amount of savings. The overall process cycle efficiency increased by 7.75%, and we'll talk a lot more about this in the second video. So that concludes the process mapping part 1 video, and we look forward to hopefully seeing you for the second video, part 2 of process mapping, where we'll be focusing more on value stream mapping. We'll be using some 3D discrete event simulation to highlight some of the differences and improvements that we can achieve using either robotics or automation or even just changing the layout or routes of where people can go in light of social distancing, and also look at some technology improvements which can also help improve the process and again also help with some of those social distancing challenges that we're facing in today's current climate.